Let us create first the 3D part model of the boost bearings body. Okay, go to new and select the part and then check the use default template and give name bush bearing body. Okay, bush body, you can do bush body. Okay, and choose the metric unit template. This is what the metric unit template, metric mm newton seconds. Okay, and then choose the front plane and draw extrude directly and create the basic structure of the element. Start with the rectangle. Its dimension should be 25 mm height and length should be 230 mm. Okay, and place it symmetric to the datum plane. Okay, then the structure to hold the bush bearing starts like this. Okay, and the structure to this holds like this. They should be 60 mm, and this length should be 47 plus 47, 94 mm, and this 94 divided by 2, so that it will become symmetric. Now you delete unwanted segments like this one, this one, this one, this one, this one, this one. Okay, this one 68 mm, make it stronger, otherwise you dimension this overall length. Okay, okay, let's make it this stronger. Okay, done, everything is fine. Okay, now give extrude of 76 mm as per the design requirement and place it, position it symmetric to this datum plane. Okay, it's done. Now again select the front datum plane, extrude the feature to hold boost bearing. Okay, its diameter should be 94 mm and its center to the bottom plane should be 60 mm. Okay, okay, now it's fine. Extrude it symmetrically for 94 mm. Okay, symmetrically. This is done. Now there is a hole of diameter 66 to hold the to assemble the bush. Okay, select dots at reference planes. From this it should be 60 mm. From this it should be 60 mm. Okay, and this 18 mm should be 0, right? So that it will become at the center. And the diameter of 66, and flat hole we make symmetric of 94 mm. Okay, in that this is what our bush bearing body. And then the next round, this one should be 5 mm radius, and this one should be 5 mm radius, and this also 5 mm, this also 5 mm. Okay, it's done. Then finally, to place a scrub screw, we have created datum plane at 60 plus 47 mm height. Okay, at 107 mm there is a plane. Now place a hole. Okay, it's done. The place position should be with respect to this datum plane, reference plane, and this datum plane should be both 0, 0. So okay, but it's a drilled hole, and the hole dia is 5 mm dia with countersunk body, and shape should be 90 degree. Okay, okay, give it 10 mm so that you can see that countersink. Okay, even you can give 12 mm so that the width accommodate the countersink there. Okay, okay, this, okay, this, okay. Otherwise, you can do through all will not work. Give blind and constrain it within 20 mm. Okay, that's all done. And the next thing is a slat. We have to create a slat. Extrude it and place it in the other way around. Place it in the other way around so that we can see what we are drawing. Draw a rectangle. Okay, this rectangle 12 minus 12. 12 means both sides 12. So 24 minus 76. Okay, this should be 76 minus 24. Okay, then we see 52 divided by 2, 26. Okay, this is done. This length should be length given. That gap should be 16 mm. Okay, so 16, 16, 32, 32 to 30 minus 32. Okay, and this should be 192, 98, 198 divided by 2. Okay, now it's okay. Remove the material of 3 mm in the reverse direction. Okay, that is the inner feature. Again, we have to create one slat. Okay, choose this plane and create a slat. Slat, you can take it from the flat shapes, raise track and place it somewhere here. Okay, close it. Now the dimensioning should be this one, should be 16 mm as per the design requirement. This one should be 26. Okay, it's done. And center to this plane should be how much it's mm? 160 divided by 2, so 80 mm. It's done. Then restart. This position should be 6 mm, right? Because it is 16. Okay, 18. Our position, everything looks navy blue, so constraint field. Okay. Now here also we have to remove the material. We can give here variable through all. Okay. Now we create a mirror of this feature to this plane. That's done. This is what the part drawing of the bush body to 3D part model. Okay. Okay. Now let us create. This is what the part model will look like for body. Okay. Now let us create the bush. Bush is a simple one here. Bush bearing. Okay. Part and create bush bearing. Okay. Bush bearing or sleeve bearing we have. Here also we select metric unit template. Okay, and choose the back plane, front plane, and extrude it. And this outer dia should be 66 so that it should assemble right. And inner dia of the bush bearing is 50 mm dia. 50 mm dia. That's all. The length should be 94. This is what push 94, 94. Okay, and symmetrically pushing. Okay, done. And here also you have to create on D10 plane. Create a D10 plane at a height of 66 divided by 2. Okay, done. There also you have to create a hole so that it will assemble the hole. Okay, the references this one and this one 0 0. Well, it is good to go. 5 mm dia, but it's a flat. It's drilled, but don't give countersum. Okay, this length you can give some 20 mm, no problem. Okay, it's done. Then we have to go for assembly. Okay, then we have to go for assembly. Okay, go to new assembly, bush the bearing assembly. Okay, bush the bearing assembly. Okay, now assembly. You remove this space, otherwise it will not work. Okay, assembly template and mum as okay, design absolute. Okay, first part we have to assemble is bush body. Okay, and here as usual we can fix it. We can fix this part, default position, and make it rigid. Okay, that's it. Done. And then assemble the bush bearing. Okay, for this you choose the axis of the bush bearing to the axis of body and make it coincident constraint, and it's done. Okay, and then you select this body to this face, make it constraint. Okay, and next you select bush bodies data plane to the there is a confusion. This you should constrain, you have to cancel it. Yes, it's better. You can hide it. Okay, now assemble bush bearing and take the axis of this with the axis of that body and make it coincident type constraint. And again you constrain this too. Okay, and the last one, 3 constraints minimum. Okay, next one is this one to this one. Okay, constraint to that, to this constraint. Remove this surface because we don't have to constrain this. You constrain this plane to this plane. Okay, at a distance of 60 mm. Okay, next one is you constrain this, to this. Okay, so you constrain. Now the part assembly ready. Okay, the whole everything falls in line. This is what assembly modeling. Then let's create a drawing. New drawing. Okay, bush bearing drawing. Bush bearing drawing. Okay, it's a simple part, right? Use template, create pattern size to work on it. I can move to this proper. Okay. Okay. Now you scale it first. Let us see how it fits. 1:1. Okay. Okay. Sounds good. Okay. You remove the left view movement and place it properly. Now we can give dimensions by unlocking the place. Okay, in this view, let us see the scale. We can place it somewhere in the corner. Otherwise, it is an assembly mode. Somewhere in the corner. Okay. It's very small, so I can't pick it up. zoom in, zoom out, and select properly. Okay, let it be there. And then dimension, you can try to give. No, it's not coming anything. So first dimension we have to give from the annotate dimension. We select these two lines. Okay, it's 230 mm, right? Give it. Okay, from slats and point, it's 160 mm, right? Give it. And this height, this is 25 mm. Okay, and this height, it is 3 mm, right? Okay, and then the slot and the other that we can do it here. Slot dimension here is 16, and from this to this it should be 10 mm. Okay, and then this radius should be 18 mm. Okay, that's done. And then diameter of this. Okay, diameter of this. Okay, diameter of the bush bearing. Okay, and this one again, the center of this, center of this to center of this to the infinity. That's fine. Okay. What else? We want the center to center distance. We can 160 mm, 60 mm. Okay, from where it starts. This edge to this edge, it should be 60 mm, right? And this overall cutout dimension is okay 158. Okay, and this to this is 12 mm. Then this radius, this fillet radius 5 mm. This fillet radius also 5 mm in two places, and this one is in this one, this length is 94 mm, and this dia is 94. Okay, so the square. Okay, then okay, then this okay, this 60 mm. Okay, done, everything done. Okay, this dia is 6. Okay, this dia is 500. This dia is this dia is 500. 500. Right, so we have given all the dimensions in this model, assembly model. And then let us give the font size to 5 mm height, so that it will be finished. Since it's an assembly model, we can give a bill of material table. Go there and select quick table and click the bill of material. Okay, and this also will be specific note in this assembly. Okay, this column we can cut it and delete it. Okay, okay, delete it. Then move it properly to the corner so that it will look nice. Now add notes. All dimensions are in. Okay, all dimensions are in. All dimensions are in mm some 6 in the font also you can change it to nice so that you place it. Okay, now you add our college name, your note, and a bundle product if you can use. Choose some 6 in and type running. Product technique. Values. Okay, choose a different font. Okay, choose different font and give different height also to look nice. Okay, and give the assembly. No, this is to D. Goes to the bearing. Goes to the bearing. Assembly drawing. Assembly drawing. We change the font size to 10 so that it can use to bearing assembly drawing. These are different font. So again, okay. Now we do the visual effect of the 2D creator. Okay, this one we will font. Otherwise, I choose fonts on also, but it will look nice. Okay, and blue type is isometric. Okay, now it's done. This is what the 3D, 2D drawing, assembly drawing of our pushed bearing. Thank you for watching. This was bush bearing assembly drawing.